Hi, grade 10. So today we're doing lesson 5.7, which is called Primary Trigonometric Ratios, and we're going to be learning about sine, cos, and tan. So if you refer to the handout that's on Teams, print it off and follow along and fill it in as you watch this video. So at the top of your handout there it says, measure to the nearest tenth of a centimeter each individual side of each triangle. Record these measurements on the drawing. So if you just pause the video for a minute and take a ruler and measure each of these segments. Here. These ones, each section. Okay, so pause and do that for a minute. All right, so now that you've measured, I'll fill in my measurements here. You probably noticed that the top small lines are all 2.5 centimeters and the bottom small lines are all 1.9, and then the vertical ones are varying lengths. So number 2 says, explain why triangle ABC, ADE, AFG, and AHI are all similar. So first we'll talk about triangle ABC, so that's the whole entire big one, so A to B to C and then back to A. How is that similar to ADE, that one there, as well as AFG, as well as AHI? Well, we know that they're similar because angle A, so this angle here, 40, is common to all four triangles. And since the vertical lines here are parallel, so those lines are ED, GF, IJ, and CB. Since the vertical lines are parallel, they all hit the top and bottom lines at the same angle. So if they have the same angles and there's a scale factor of each other, then they're going to be similar triangles. The ratios of the side lengths are equal. All right, now we're going to complete the table underneath that. So it says complete the table below to determine the ratios of corresponding sides for each triangle. So this is setting us up to learn about sine, cos, and tan. So we're just going to fill in the measurements that are given to us above where we just measured. So when I have a triangle, if I'm talking about angle A, this one here, then the side opposite to A is the one that A is not touching, so that's opposite. The side adjacent to A is the one right beside it that's not the hypotenuse. So this one's adjacent, the one it's touching. And then the one opposite the 90-degree angle is the hypotenuse. Okay, so that's what we're talking about when we say adjacent, opposite, and hypotenuse. So first in triangle ABC, so that's the biggest triangle, the whole thing. The side opposite to A is this one, and that was 6.3. So we'll fill in 6.3 here. The side adjacent to A was 1.9 plus 1.9 plus 1.9 plus 1.9, which is 7.6. And the hypotenuse is 2.5 plus 2.5 plus 2.5 plus 2.5, which is 10. Now, we're going to talk about some ratios. So opposite over hypotenuse is like opposite divided by hypotenuse. So from this same row, we're going to do the opposite, which is 6.3, over the hypotenuse, which is 10. 6.3 divided by 10 is 0.63. So opposite divided by hypotenuse is 0.63. Next, we're going to do adjacent over hypotenuse. So adjacent was 7.6 over hypotenuse, which is 10, equals 0.76. And then opposite over adjacent, opposite is 6.3, adjacent is 7.6. 6.3 over 7.6, do that division on your calculator, and that's 0.83. Okay, next row. Triangle ADE, so that's this first little one here. The side opposite to A would be line ED, which was 1.7. The side adjacent to A, so that first little one there, was 1.9. And the hypotenuse of that triangle was just the little one, was 2.5. So the opposite divided by the hypotenuse is 1.7 divided by 2.5, which is 0.68. Adjacent divided by hypotenuse is 1.9 divided by 2.5 equals 0.76. And opposite over adjacent is 1.7 over 1.9, which is 0.89. Okay, triangle AFG, the next one here. AFG. So the side opposite to A would be GF, was 3.2. The side adjacent to A was 1.9 plus 1.9, which is 3.8. And the hypotenuse is 2.5 plus 2.5, which is 5. Now the opposite divided by hypotenuse is 3.2 over 5, which is 0.64. Adjacent over hypotenuse is 3.8 divided by 5, which is 0.76. And opposite over adjacent is 3.2 divided by 3.8, which is 0.84. And then the last triangle, AHI, goes all the way to here and up. Opposite is 4.8. Adjacent is 1.9 plus 1.9 plus 1.9, which is 5.7. And hypotenuse is 2.5 plus 2.5 plus 2.5, which is 7.5. So opposite over hypotenuse is 4.8 over 7.5, and that's 0.64. Adjacent over hypotenuse is 5.7 over 7.5, which is 0.76. And opposite over adjacent is 4.8 over 5.7, which is 0.84. All right, so number 4 says, what do you notice about the corresponding ratio values of each triangle? Why is this? So that means we're going to be looking at these 3 columns here. And what do you notice? Any sort of pattern in this section? So if we look down this first column of opposite over hypotenuse, those values are all pretty close. 0.63, 0.68, 0.64, 0.64. If you look down this column, those values are all the same, 0.67. And if you look down this column, those values are also very similar, 0.83, 0.89, 0.84, 0.84. So, what do you notice? They are the same value. Or they're the same. And why is this? It's because we're using the same angle for all of them. So the ratios of each triangle are the same because they're similar triangles using the same angle. Okay, on to the back of the page, or the second page, in the box where it says key ideas. The term trigonometry is made up of the Greek words trigon, which means triangle, and metric, which means measure, so triangle measure. For any right triangle, there are 3 possible ratios of side lengths that can be considered. So this only works for right triangles. And there are 3 possible ratios. We have sine, which is the ratio comparing opposite side to the hypotenuse side. And remember that we can always write a ratio as a fraction, so 1 over the other, opposite over hypotenuse. Cosine is the ratio comparing the adjacent side to the hypotenuse side. And tangent is the ratio comparing the opposite side to the adjacent side of the angle that we're talking about. So the next point says, record the 3 primary trigonometric ratios for both angle A and angle B for the triangle below. So I'll just draw the triangle for a second. This is triangle ABC. Angle C is the 90-degree angle. And then we label the side lengths with lowercase letters that are opposite the angle. So see how lowercase b is opposite uppercase b, lowercase c is opposite uppercase c, and lowercase a is opposite uppercase a. All right, so we need to use both angle A and angle B. So first we'll do angle A. So we write sine A, because that's the angle, so the short form for sine is sin. Sine A equals, so sine was the ratio comparing the opposite side to the hypotenuse side. So the opposite of angle A is the only side it's not touching, so that's side A, lowercase. That's the opposite side over the hypotenuse side. The hypotenuse is the side that's opposite the 90-degree angle, so that would be A over C. Next we'll do cos A. Cos is the ratio comparing the adjacent side. So adjacent to angle A is the one that's touching A, but it's not the hypotenuse one. So that would be B over the hypotenuse, we decided was C, B over C. And then tangent A, or tan A, is the opposite over adjacent. So the opposite side was A, and the adjacent side is B. So A over B. Okay, next we'll do angle B. So sine B now, we need to look at the opposite over hypotenuse. So the opposite of B is lowercase b over the hypotenuse is C. Cos B, cos is adjacent over hypotenuse. So the one adjacent to B is the one that's touching it. That's not the hypotenuse. So A over the hypotenuse, which is C. And then tan B is the opposite side. So that would be lowercase b over the adjacent side, which is A. All right, so the 3 primary trig ratios, so sine, cos, and tan are the 3 primary trig ratios, are easily summarized using the acronym SOHCAHTOA. This is what you write in the blank. SOHCAHTOA. So what does that mean? S is for sine, opposite hypotenuse. Cos, adjacent hypotenuse. Tan, opposite adjacent. So it's telling you which ratio you use for each one. So for sine, you do opposite over hypotenuse. For cos, you do adjacent over hypotenuse. And for tan, you do opposite over adjacent. Okay, so if you remember the word SOHCAHTOA, then you'll always remember the ratios for each trig ratio. Right? Next point says, when you're given the ratio but you need to find the angle, use the opposite operation of the trig ratio, which is called the inverse ratio, to isolate and solve for the angle. So the inverse ratio, for example, if you're given tan x equals 1 over 12, now you don't know what x is, which is the angle. So you don't know which angle you're dealing with, but you need to find it. Then you would say x equals tan inverse bracket 1 over 12. So you just move the tan to the other side by doing the inverse, and this is a button on your calculator that you'll use. Now go to your calculator, x equals, and then you probably have a tan button, and you'll probably have to hit shift in order to get tan inverse. So shift and then tan bracket 1 divided by 12 bracket equals, and you should get 4.75 degrees. Now, if you're not getting that, your calculator might be in the wrong mode. You need to make sure your calculator is in degrees. So at the top of your calculator, there should be a little something that either has a D or DEG. If it says anything like RAD, like radians or rad or gradians, then you'll need to change it. So you can just send me a message and maybe a picture of your calculator so I know which one you have and I can help you figure it out. Okay, the next one beside it says sine theta equals 1 over 2. So theta is just another word for a missing angle. So it's like x. So it just means we don't know this angle. It's actually a Greek letter that represents a missing angle. So now we would say theta equals sine inverse of 1/2. So again, on your calculator, you'll probably need to hit shift and then sine bracket 1 divided by 2 bracket equals, and you should get 30, and that's 30 degrees. And then next to that, we have cos A equals 1 over the square root of 2. Again, we want to find that missing angle, so we need to do the inverse ratio. So we'll do A equals cos inverse bracket 1 divided by the square root of 2. On your calculator, you'll hit shift, then cos bracket 1 divided by the square root of 2 bracket equals, and you should get 45 degrees for an answer for that one. So that's how you find the missing angle. And then the last point in the box, the slope of a line is the tangent of the slope angle that the line makes with the x-axis. Okay, so what does that mean? So if I have a axis here, this is the x-axis, and then I have a line like this, the slope of the line is the tangent of the slope angle. So if the angle is 20 degrees, then the slope of this line equals tan 20. And then if you type in your calculator tan 20, then you would get 0.36. That means the slope of this line is 0.36, the green line here. Okay? All right, example 1. Find to the nearest degree the angle of inclination of a ramp with a slope of 1 to 12. So a ratio of 1 to 12, ratios can be written as 1 to 12 or 1 over 12. That's the same thing. Okay? So if I have a ramp, so it needs to have the ground, the ramp is going up like this, and I need to find the angle of inclination. So starting at the ground, the angle going up. This is the angle I need to find. So I'm going to call it x, and then I'll close this in to make it a triangle. Now, tan, we're going to use tan because of what we just learned with the slope angle. So it says the slope is 1 to 12. So slope equals 1 over 12. So that means that tan x equals 1 over 12. I don't know the x, I don't know the angle, but I can find it using the inverse ratio. So I'll do x equals tan inverse 1 over 12 in brackets. On your calculator, shift tan 1 over 12, and you will get 4 0.76 degrees, which is rounded up to 5 degrees. So that means this angle it's a 5-degree angle of inclination for the ramp. Number 2, find the equation in form y equals mx plus b of the line that makes an angle of 35 degrees with the x-axis and passes through the point 0, -2. So the angle with the x-axis equals 35 degrees. So there's my x-axis. My line is coming through and it has an angle of 35 degrees. So in order to put this in y equals mx plus b form, I'll need the slope. Now we just learned that you can find the slope of this red line using tan of this angle. So if we do tan 35, so on your calculator you type tan 35 and that will give you 0.7. So the slope is 0.7. So far I have y equals m, which is the slope, 0.7x plus b. And then I'll insert that point that they gave me, 0, -2, for x and y, and then I'll be able to find what b is. So the point is x comma y, so it will be -2 equals 0.7 times 0 plus b. -2 equals 0.7 times 0 is 0 plus b, so -2 equals b. So therefore my equation is y equals 0.7x minus 2. Okay, on to the last page, number 3. Determine the angle at which y equals 2x minus 1 and y equals 0.5x plus 2 intersect. To begin, sketch the situation. So y equals 2x minus 1 and y equals 0.5x plus 2. So first we're going to start by graphing this. So we're going to have to remember how to graph a line in y equals mx plus b form. So just draw a little sketch of a graph. I'm just going to go up by ones. So 2, 4, 6, -2, -4, -6, 2, 4, 6, -2, -4, -6, x, and y. All right, so starting with y equals 2x minus 1, we start with the y-intercept, which is -1, and then we use the slope, which is rise over run. So the slope is 2. Written as a fraction, that would be 2 over 1. So we go up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. And then connect those dots with a line. Then we do the other one, which is 0.5x plus 2. So the y-intercept is 2, and the slope is 0.5, which is a half, which is 1 over 2. So we're going to go up 1 over 2, up 1 over 2, up 1 over 2, and then connect those with a line. All right, now we're going to find the angle at which these hit the x-axis here. So we can do that because we know the slope, so now we can find the angle using tan. So for the first one here, the slope equals 2, so that means tan x equals 2. So to find missing x, we can use the inverse ratio. X equals tan inverse of 2. Type that into your calculator and you will get 63 degrees. So that means that this orange line makes an angle of 63 degrees with the x-axis. For the second line, the slope equals 0.5. So that means tan x equals 0.5. So to solve for x, we can use the inverse ratio and type that into your calculator and you will get 27 degrees. So this one here is 27 degrees. Now, if I just shift this up here, to the point where they intersect. Then the yellow one here is 27, and the orange one is 63. So I need to find the little angle that's between the two, which is right here. So I'll do 63 minus 27. Right, because I have this total 63 minus this part 27 will give me this one in here. So 63 minus 27 is 36 degrees. So therefore they intersect at 36 degrees. Intersect at 36 degrees. All right, number 4. Determine the value of x to the nearest centimeter. So we have 15x, and this is an angle of 32. So we only know one angle. Well, we know the 90-degree angle, but we're going to use the angle that's given to us, which is 32 degrees. And now we have to determine which ratio we're going to use. Are we going to use sine, cos, or tan? So I'm going to write SOHCAHTOA up here. And looking at the 32-degree angle, I need to find the x, which is opposite, and I have the one beside it, 15, which is adjacent. So I need to check SOHCAHTOA to see which one involves opposite and adjacent. So which one has O and A. So not sine, not cos, but tan, O and A. So that means I'm going to use tan. So I'm going to write tan 32 equals opposite over adjacent. Tan 32 equals the opposite, which is x, over the adjacent, which is 15. Now I need to solve for x, so that means I need to get x by itself. In order to get rid of this 15, I'll multiply both sides by 15. These two 15s cancel out. Now I have 15 tan 32 equals x. You can type this whole thing into your calculator, 15 tan 32, and you will get a number which should be 9.4. And that is how long side length x is. So the missing side length is 9.4 centimeters. And then number 5, calculate the measure of A to the nearest degree. So this is C, B, A, this one's 12, and this one's 5. So I need to find A. So what do I know in relation to A? Well, I know the opposite, and I know the hypotenuse. So which ratio involves opposite and hypotenuse? Look at SOHCAHTOA. I need O and H, so that would be sine. So for this one, I'm going to use sine. So sine A, which is the angle, equals opposite over hypotenuse. So sine A equals the opposite is 5 and the hypotenuse is 12. Now when I don't know the angle, I use the inverse ratio. So I'll say angle A equals sine inverse of 5 over 12. And then you'll plug that into your calculator using shift sine bracket 5 divided by 12 bracket, and that equals 25 degrees. So the angle A equals 25 degrees. All right, let me know if you have any questions, and check teens for your assignment, and I hope you have a good day.